All right, for lesson 3 in Unit 10, focusing on surface area and volume, we're going to bounce from surface area and start talking about volume. And we're going to focus on prisms and cylinders. Those are going to have the same formula. And then pyramids and cones, those will have the same formula. And so we're adding 2 more formulas to the mix. We already have, I know that it looks like there's 4 formulas, but there's actually only 2. We're just differentiating perimeter versus circumference in both of those formulas. And then we're going to have 2 new formulas today. So we have these formulas for surface area, for prisms, cylinders, pyramids, and cones. But now we're going to add some more to the mix on the volume for prisms and cylinders and also for pyramids and cones. What we're going to notice is that the volume of a prism or a cylinder is found by taking the area of the base and multiplying it by how tall or the height of that prism or cylinder. In a pyramid or a cone, it's basically the same idea, but it's a third of the area of that base times the height of that pyramid or cone. Now this might be a little bit of a struggle because when we found surface area, we focused on the slant height, the L value, when we were working with surface area for pyramids and cones. But here we're going to be using the actual height of the cone or the actual height of the pyramid. And so be aware of that. But there is a 1 to 3 relationship here, one of these to 3 of those, or sorry, one of these to 3 of those, to consider volume as a little experiment. What we can do is I can basically take a, let me see if I got another example over here. I can actually take a pyramid and fill it up 3 times to fill up this prism that has the same base and the same height, and I can scoop up water 3 times and it would fill up this, this solid. All right, so there's kind of a neat trick that we can do with our volume here, a little experiment that we can do in class when we are together. But those are our 2 formulas. So you'll notice that these are the same for prisms and cylinders. These are the same for pyramids and cones. So the next time that you see this, we're probably going to cut off the C versus the P there, and it's just going to be 4 formulas instead of what looks like 8 formulas. All right, I don't want that to overwhelm you. We got 2 new formulas today. And so we're going to run down that rabbit hole here in just a little bit. For each of these, I was able to just put all the formulas into the work. Here is not a right cone. This is an oblique cone where the altitude is drawn, or where the vertex is not actually over the center of the cone. And this is not a problem, but it's still just a cone. And we still have the formula of doing 1/3 times the area of the base times the height, which means I need to take 1/3 times pi times this radius squared times this height. And then I get to use the diameter divided by 2 gives us the radius. The height, we know what that is already. And we get to type that into our calculators. 1/3 of 225, that does divide. And then multiply that by 25, whoops. And that gives us 1875 pi. But now since we're dealing with volume, we don't have square units, we've got cubic units. So our feet are cubed. Our feet are cubed. We have 1,875 pi cubic feet. In this situation, we have a square pyramid. This should look somewhat familiar. We've got the side length is 40. The slant height is 25. So even though this is a square pyramid, and we have this formula of 1/3 times the area of the base times the height, remember, this is not base, it's area of the base. We are given the slant height, we need to figure out what the height is using the Pythagorean theorem. So if I want to know what the height is, then I have to cut this 40 in half. All right, 20 and 20. I got to find the height. H squared plus 20 squared equals 25 squared. Doing some Pythagorean theorem there, we're going to find out that H is equal to 15. And that is using, obviously, a 3, 4, 5 triangle relationship. 3 times 5, 4 times 5, 5 times 5. Or we could go through all the steps of the Pythagorean theorem. But once we've got that, we know that the volume is equal to 1/3 times the area of the base, 40 times 40, times 15. Okay, great. So 40 squares easily. We can divide the 15 by 3, or the 1/3 times 15 gives us 5. 5 times 16 gives us 80, so 800 or 88,000 here, 8,000 cubic feet. Again, trust your calculator there. This is a rectangular prism. So our base is a rectangle. The volume is going to be the area of our base times the height. All right, the area of our base, we call this side, or this face here, if I call this the base, we'll multiply that area of this base, 20 times 10, by how far it is between those parallel bases. And so that gives us our grand total. Now you probably have seen this formula as length times width times height. That obviously works here. We're taking the length times the width times the height. We're multiplying those numbers. It doesn't matter what numbers are where. It doesn't matter which faces we choose as bases, as long as we understand that we're finding the area of the base and then multiplying by the height. All right? But I don't want you to consider it as length times width times height. I want you to think of it as the area of the base times the height. If you know, or if you write your formula in this way, then when you're dealing with cylinders, that's going to be the same exact thing, all right? So you don't have to have a separate formula for prisms versus cylinders. Here, this is a triangular prism. So again, we have to find the area of the base, and the base is not the bottom. The base in a prism is the congruent parallel faces. So in this case, it's the triangles. And so the area of that triangular base is going to be 1/2 times 6 times 10. It's going to be the area of this triangular base, and then we multiply it by the distance between those parallel faces, so times 5. Half of 60 is 30. 30 times 5 is 150. And put on our cubic units, because we're dealing with volume. We've got meters times meters times meters, makes meters to the 3rd power, meters cubed. Next one. This is a cylinder. The formula is still area of base times height. It's just that we know how to compute the area of the base as pi times the radius squared times the height. So pi times 3 squared times 8 is going to be pi times 9 times 8, which gives us 72 pi cubic centimeters. I can go all day. Example, example, example. All right, all that we need to do is convince ourselves that these formulas work. All right? And we don't have to worry about saying the formula for a cylinder is different from the formula for a rectangular prism, is different from the formula for a triangular prism. It's all the same concept. Find the area of the base, multiply by the height. If it's a pyramid or a cone, or a pyramid or a cone, you have to do 1/3 times the area of the base times the height. All right, as we have here. So here you're given that the h is 12, the side lengths of the base are 8. This pyramid is upside down. It doesn't change its volume because it's upside down versus right side up versus tilted to the side. And so when we find the area of the base of 8 times 8, we multiply it by the height of 12. We multiply those by 1/3, and it will give us 1/3 of 64 times 12, which gives us 4 times 64, or 256 cubic inches. You'll notice that I'm doing a little bit of multiply what I can by 1/3. I can do this in my head. 1/3 of 12 is 4. 4 times 64 gives us 256. And so sometimes it works out nicely where we get to actually divide one of these numbers by 3. Other times we have to have these numbers over 3, like this as the numerator over our denominator, and there's no common divisor in there. And that can be a little frustrating from time to time because it kind of makes our work look a little ugly. But we can have improper fractions here. That's totally appropriate. All right, that's all that we needed to focus on was making sure that we could find the volume for square pyramids and well, I'm sorry, not for square pyramids, but for pyramids and cones, for prisms, for cylinders, following through all those steps and making sure that we feel comfortable with each of those formulas.